DNS is surprisingly simple to understand. It plays a major role in most people's lives, and yet it seems like very few people actually understand how it works. To give you the quick answer, DNS stands for Domain Name System, and simply put, it's a system of translating domain names such as youtube.com or google.com to their respective IP addresses so that your device can connect to them. But that's a very technical way to put it, so let's dive a bit deeper. Why do we want an IP address? I'll start my explanation with a question. Could you do me a favour and call my mate John? Even if you wanted to do it, you wouldn't be able to since you don't know his phone number. And just like how people contact other people with a phone number, computers contact other computers using IP addresses. So when you search google.com, it doesn't actually mean anything to your device, which is where DNS comes in. Before we can understand how this process works, we need to understand what a domain name is actually comprised of. Domains are made up of three parts: a subdomain, the domain, and a top-level domain. Subdomains are optional, however, they can be useful for routing incoming traffic. Each of these parts play a key role of how your device gets the IP address it needs. Before we start, we also need to cover the purpose of using www. If you search google.com, it will take you to their search engine, but you'll notice in the URL, it actually starts with www. If you're using Chrome, you need to click in the URL to be able to see this. This is a bit of a relic from when www. was used to help people specify that they wanted to view the website and not use a different service. But as we previously mentioned, the subdomain is not needed to make the request, so most websites automatically redirect you to the www. Subdomain so that all users end up in the same place, no matter what they search. If that seems a little confusing, that's because it is. So as a general rule, you can think of putting www. as a subdomain the same as putting no subdomain at all, but this definitely isn't a strict rule. It is, however, what most large companies do, such as Google, YouTube, Microsoft, and more. Also let me know in the comments if you want a full video to explain this better and the history of domain names and internet protocols. Finally, we can begin our journey. So we want to go to myaccount.google.com. So we type that out into a search engine and hit enter. The first thing that happens is your device will search its local cache of domain names for an IP address. If we were to use the phone call analogy again, it's as if I were to ask you to call the same phone number multiple times. Eventually, you would begin to remember it and wouldn't need to ask me what it is. So by searching its cache, it's effectively checking whether it knows the IP address already, from the user already searching it. There are multiple places it can search to do this. The first is in the browser itself. In fact, you can find out what IP addresses your browser currently has cached. On Firefox, you can search this, and on Chrome, you can search this. If the browser cannot find it in its cache, then it will check the operating system's DNS cache. If it's not found there either, the query will be sent to your router. Some routers also have an internal cache, but if yours doesn't, or if it's not in the router's cache, then the router will hand it off to a DNS resolver. If you've not changed your DNS settings on your device, this will probably be your ISP's default resolver server. But if you have changed them, then this will be the DNS resolver that you have set, such as Google, Cloudflare, or my personal favourite, Quad9. Although there are different options, they all do the same task. They query three different servers: a root server, a top-level domain server, and an authoritative server. The names are a little confusing at first, but let me explain. A root server actually contains a list of IP addresses for each top-level domain server. Then there's the top-level domain server. They contain a list of all the authoritative servers that use the top-level domain it has been assigned. For example, the .com top-level domain server will contain the IP address for each of the authoritative servers for google.com, amazon.com, and all others that end in .com, while the .org top-level domain server will contain the IP addresses for each of the authoritative servers for wikipedia.org, archive.org, and more. Finally, there is the authoritative server, which contains the actual IP address of the domain. So when you search myaccount.google.com and the IP address isn't found in the local cache, this is what actually happens. Your DNS Resolver asks any root server what is the IP address of the top-level domain server that manages .com, and the root server responds with an IP address. Then your DNS Resolver asks the top-level domain server what is the IP address of the authoritative server that controls google.com, and it responds with an IP address. Finally, the DNS Resolver asks the authoritative server what is the IP address of myaccount.google.com, and it gives a final IP address back. The DNS Resolver then sends this IP address back to your device. If you're interested in understanding a bit more about root servers, then there is lots of information out there. You can find a list of all their domains here. On that page you'll find a list of 13 different domains and their IP addresses. However, it's a little deceiving. Although there is only 13 IP addresses, there are actually thousands of root servers. You can find a map showing all their locations here. When the DNS Resolver uses the IP address for a root server, the request is routed to the closest one. This is done to help increase speeds, but they all function the same. You can also find a list of all the top-level domains here. And here is a Wikipedia link that explains more about each one. Anyway, now that we understand how this works, let's see it in action. Here I have SSH'd into a Raspberry Pi. On one side I have the terminal open, and on the other I've opened the DNS settings. When I tried to ping google.com, you can see that the ping goes through with no problems, since it can translate the domain name to its IP address. However, if I remove all the DNS Resolver options, then you can see that I am no longer able to ping google.com. However, that doesn't mean we aren't able to ping the servers at all. Because we can see their IP address in the previous ping, we can use the IP address in our next ping. And now you can see it goes through. This is because we are doing the job of DNS for it. I also mentioned recently in my Why You Might Want a Server video that I use a DNS Ad-Blocker that also encrypts all my domain requests, so I'll explain that some more now. I use AdGuard Home. It is a free and open source software that plays a simple but important role. When I search for a domain and none of my local caches have it stored, instead of my request going to a DNS Resolver, first it goes to my server. My server then makes the request for me. However, traditionally, DNS requests were made in plain text, which meant that anyone in the middle, such as an ISP or a network admin, could see the domain that you were requesting. It also meant that it was extremely susceptible to man-in-the-middle attacks. Thankfully, since 2020, both Firefox and Chrome are using DNS over HTTPS by default. Naturally though, this only protects the DNS requests made using the browser, so all other DNS requests that your device makes are left completely exposed. So by sending the request to my server, I can be sure that all requests made are encrypted. On top of that, it blocks a large majority of ads. It does this by checking every domain request made against a list of domains that serve ads. As an example, imagine you are loading a news page. On that page, there will be ads. However, most ads on a website page are never actually built into the page, so the website must make more DNS requests while the page is loading to get that content to the page. When the domain requests are being made through AdGuard Home, it will check the domain against its database and block the request from ever being made if it matches. So let's see it in action. Here I have opened google.com. I am able to reload the website with no issues. However, if I add the domain to AdGuard Home, and then clear my cache, you can see I'm now unable to load the website. This is the same premise that is used for its ad blocking capabilities. So to summarize, DNS is the process of translating a domain name to its IP address. This is done by checking caches and then using a DNS resolver to contact root servers, top-level domain servers, and authoritative servers. However, this process can be used to help your privacy and security. Thank you for watching, please like and subscribe.